Hi, welcome back. In this video we're going to look at solving radical equations. And simply radical equations are just those that involve radical expressions, like you see here in these examples. So here we have a square root with the variable inside the radical. Here's a cube root. All right, a couple of square roots up here. How do we handle those? Well, the first step in solving a radical equation is to isolate the radical term, and that's the most important. So we want to isolate the radical term. Get the radical term on one side of the equation by itself. If we do that, we can then raise both sides by the appropriate power. So we know that a square root, right, the inverse operation to that would be to square it. So if we have a square root on one side by itself, we can square both sides. That will cancel out the square root. A cube root, I'll give you kind of a hint there. We need to raise both sides to the third power to get rid of it. And whatever the root is, you can figure out what power you need to raise it as. In the next set of examples, after this, in the next video, we're going to look at fractional exponents and how to handle those, very similar to radicals. In fact, we'll see how we can convert square roots or cube roots or whatever kind of root into a fractional exponent, and that is an extremely useful tactic. All right. The last thing that we need to do, and this is also important, is that we need to verify the solutions. As we know, if we have a square root, that limits the things that can be put under it, right? Because a square root cannot, we cannot take the square root of a negative number. Cube roots, not very much of a problem because we can take the cube root of any number, positive, negative, or zero. All right. So it's typically the even roots that give us problems. But in any case, we should just verify the solutions anyway, make sure that we have the right answer, whether we have square roots or cube roots or whatever in our equation. Okay, so isolate, raise both sides to an appropriate power that cancels out the root, and then verify. These are our method for these. All right, let's look at the first example we have here. We want to solve this equation. We have 4 plus the square root of x minus 2 equal to x. Okay, so first off, we notice that it is a radical equation because it has the square root of x minus 2 in the equation. We see that it is not by itself, right? It is, it's there with this 4. It's 4 plus this radical expression. We want to isolate that, right? We can isolate that easily by subtracting the 4. So we'll have the square root of x minus 2 equal to x minus 4. All right, so we have isolated the radical term, and now we raise both sides by the appropriate power. Since we have a square root, we'll raise both sides to the second power. All right, on the left-hand side, the square root and the square cancel each other out. On the right-hand side, we have x minus 4 squared. Right, now this is going to be right here. This part right here is going to be, we'll have to multiply that out, right, using FOIL. Okay, so that's going to be x minus 2. And the right-hand side, we'll multiply it out. Well, since it is a binomial square, we could just use the binomial theorem. So x squared. Then we have 2 times negative 4 times x, so negative 8x. And then negative 4 times negative 4 plus 16. All right, this is now a quadratic equation, and we can use all the methods that we've learned up to this point to solve this. So we'll subtract the x, and we'll add the 2. So subtract x, add the 2. So 0 equals x squared minus 9x plus 18. All right, and now we can use whatever method we like to solve this quadratic. Let's see, so we need pairs of factors of 18 and add up to negative 9. So negative 9. So it looks like they would both need to be negative. So we have negative 2 and negative 9. So have negative 3 and negative 6. So 0 equals x minus 3, x minus 6. Okay, and this leaves solutions x equals 3 and x equals 6. Okay, at this point we want to check these solutions in the original equation, make sure that they indeed verify or work. So we'll try 3. So we have 4, let's put a check right here. So 4 plus the square root of 3 minus 2 equals 3. 3, right? Yeah, 3. Okay, so 4 plus square root of 1 equals 3. So we have 5 equals 3. That is not right. So that is not good. That is false. So this solution is out. And we'll try 6. So we have, let's just work through here, 4 plus the square root of 6 minus 2, which is 4, equals 6. So 4 plus the square root of 4, which is 2. 4 plus 2 is indeed 6. So this x equals 6 is in the solution set. So that is our solution. Okay, so we had to throw out this x equals 3. All right, let's look at the next one. Here we have the square root of 9x plus 4 equals the square root of 7x plus 1 plus 1. All right, now you see in this radical equation we have two radical expressions. Unfortunately, they cannot be combined, so we cannot subtract one over and then somehow combine those. What we'll need to do, though, is try to get rid of one of them and then perhaps work a little bit more and get rid of the other. Right? So what we want to do first is isolate one of the radical expressions. And you can see that's already happened. We have a radical on the left-hand side by itself. Everything else is on the other side. Then we proceed the same way. We're going to raise both sides to whatever power gets rid of that root. So we need to raise both sides to the second power. That means the whole right-hand side gets raised to the second power, so you may have to multiply out that, and we'll have to do that here. Okay, square root and a square cancel each other out, so we have 9x plus 4. And then the right-hand side will multiply out. So we have this times this, so square root of 7x plus 1 times square root of 7x plus 1, that's just 7x plus 1. Okay, group together. And then we have plus, we'll have 2 times the product of these two, so 2 times the square root of 7x plus 1, and then plus 1 squared. All right, now you see we've gone from an equation with 2 radical expressions to just 1. And now, go through the procedure again. Isolate the radical expression, and then square. Okay, so it looks like we have a 7x that needs to be subtracted to the other side. We've got 2 plus 1 plus 1. That'll also need to be subtracted. So we have 9x minus 7x, that's going to be 2x. And then 1 plus 1 is 2. Subtract that over, we get plus 2. It's going to equal to 2 square root of 7x plus 1. All right, the radical is still not isolated. It's still multiplied by 2, so we can divide both sides by 2. And if we do, we get x plus 1 over here. So x plus 1 equals square root of 7x plus 1. All right, and now we can square both sides. So square, square, we get, let me go ahead and multiply this out. We've got x squared plus 2x plus 1 equals 7x plus 1. All right, and now we're down to a quadratic, and we can solve these as we have before. So minus 7x So we'll have x squared minus 5x, and then subtract the 1, we get 0. So 1 plus 1 plus 1, those are going to just cancel away. And this easily factors x minus 5. Remember, if we don't have a constant term, we'll just need to factor out common factors, in this case just x. So x equals 0, and x equals 5 are our possible solutions. And then we need to plug these back into the original to check. Let's try x equals 0. So we'll have the square root of 4, so 0 here, and for the x, cancels out this term, square root of 4, equal to square root of 1 plus 1. Well, square root of 4 is 2, and square root of 1 is 1, plus 1 is also 2. So x equals 0 is a solution. All right, let's try x equals 5. So here we have the square root of 5 times 9, which is 45, plus 4 equal to square root of 35 plus 1 plus 1. So square root of 49 is 7. Square root of 36 is 6 plus 1 plus 1. It will be 7. There we go. And 7 equals 6 plus 1. Also works. All right, so in this example, both answers are indeed solutions. All right, let's look at the last example. Cube root of 3 minus 2x minus cube root of x plus 1. Here we need to isolate one of these radical terms, and it turns out if we add this to the other side, we isolate both. Good scenario. So just move this negative cube root of x plus 1 to the other side. We've isolated the radical terms. Now we can raise both sides to the appropriate power. Now a square won't do it here because we have a cube root. So we need to raise both sides to the third power. That will eliminate the cube root. We'll have 3 minus 2x equals x plus 1. And this is just a linear equation. We can handle that very simply. So we'll add the 2x, subtract the 1. So we get 2 equals 3x. And so x equals 2/3. All right, and we should check. So we have cube root of 3 minus 2 times 2/3, so that's 4/3. Is that minus cube root of 2/3 plus 1 equals 0. Excuse me. So 3 minus 4/3, so that's going to be 9/3, will be cube root of 5/3. And then over here we have 3 over 3 plus 2/3, so minus cube root of 5/3. And so we've got cube root of 5/3 minus the cube root of 5/3. That is indeed 0. So x equals 2/3 is our solution. All right. So we have solved radical equations. We did that by isolating the radical term in each case, raising both sides by the appropriate power, and then verifying the solutions. Each of these 3 steps is very important. Okay, from here we're going to look at some other radical equations. Although they may not look like it initially, they will have fractional exponents. Those we'll handle similarly to these, so stay tuned for that.